Okay, so hi there everyone. We're now on our next video in our lecture in non-singular matrices in the course Linear Algebra. So we're now here in the continuation. If you haven't seen the first video on matrices, I suggest you go back on the video before this so that you can see the whole picture. And we were actually talking about non-singular matrices, or the other name for that is invertible matrices. So we're now down here in theorem 1.5, and this theorem tells us that the inverse of a matrix, if ever it exists, will always be unique. So this means that a matrix, if it has an inverse and if ever it exists, it will always be unique. So when you say unique, there's only one and only one inverse for that. So the proof is actually left for the students as an exercise. I'm gonna give this to my students for them to show that it's always unique in this case. Which is actually pretty much straightforward. It's just one example of the uniqueness proof. And as a remark for this, it follows from this uniqueness from Theorem 1.5 that we can actually write the inverse of A. Since the inverse is unique, we can write it as A inverse, or A raised to -1, but we read it as A inverse. That's a common nomenclature in abstract algebra as well. So thus we say, instead of our conventional way of writing it in the previous video, we say it like A times B is equal to B times A, which is equal to I sub n, whatever, where n is the dimension of these both square matrices. So instead of writing that, we can just say A times A inverse is equal to A inverse times A, which is equal to I sub n. Okay, so let's show an example of this, and what we want to do is we want to find the inverse of A, if ever it exists, and we're gonna show how to do that. So first, let's suppose that we have a matrix A, which is a 2 by 2 matrix. Obviously, we have the entries 1, 2, 3, 4, and we want to find inverse, or A inverse, if ever it exists. So let's start with the solution right here. And if A inverse exists, it will be in the form, of course we're expecting a 2 by 2 matrix, so it would be in the form of A, B, C, D. Okay, that's straightforward. And since we know that A times A inverse is equal to A inverse times A, which is equal to I sub n, we can use that as an advantage to answer or find the inverse of A if ever it exists. So thus we must end up with this equation. A times A inverse is equal to, our A is, remember, is 1, 2, 3, 4. So I'm going to write that 1, 2, 3, 4 multiplied by A inverse, A, B, C, D. And it should be, the dimension, notice, is 2 times 2, or 2 by 2. So we want to expect it to be ending up with I sub 2, which is equal to 1, 0, 0, 1. So putting this as an advantage to find the value of A inverse, this would look like 1, 2, 3, 4 multiplied by A, B, C, D, which should look like 1, 0, 0, 1. Okay, so what we want to do is just apply matrix multiplication on the left hand side of this equation right here. So what we have is 1 times A plus 2 times C. Where did I get that? Again, here, I'm just gonna highlight that so that you can see where it came from. Entry 1, 2, we have 1 times B plus 2 times d. So where did I get that? It's over here. Next, entry 2, 1, 3 times a plus 4 times c. Where did I get that? It's over here. And lastly, 3 times b plus 4 times d. Where did I get that? It's right over here. Okay, and this will be equated to 1, 0, 0, 1. Now, from this, we will actually, using the idea of augmented matrices, we can actually equate these entries into into linear systems. So what we will end up with is actually the first linear system that we're gonna see is, this one connected to this one. So we are having, thus we have a plus 2c. Let me clear out anyway any coefficient with 1. So I'm not gonna write 1 anymore. That one. The other one is using this as the left hand side and this is the right hand side. So clearly what we have is 3a plus 4c equals 0. Okay, and we have another linear system of this one aligned with this one. So what we have is b plus 2d equals 0. And lastly, we have this aligned with this. 3b plus 4d equals 1. By the way, why are we pairing them? Because this portion have the same variable. So both the first terms have a, both the second terms have c. So we should put them on the same linear system. Similarly, on the second one right here, both first terms have b as the first variable or first unknown, and the second variable or second unknown is both or are both d. So we should align them. Okay, so what we want to do is to find the values of these a, b, c, and d. So you can use elimination or substitution with this, which we will show one by one. Let's start with this one. So I'm going to use substitution, and I like to see that I like the way a is actually situated on the left side here, because a has already a coefficient of 1. So we're gonna make use of that. Thus what we have is a from this equation, we can just transpose the 2c to the other side. So what we have is negative 2c plus 1. So I'm gonna apply that in the second equation, using a in I'm gonna call this 1 and 2. In 2 we have 3, sorry, I'm not gonna use that, 3 times negative 2c plus 1 plus 4c equals 0. So what we want to do is to determine the value of c. So doing the math, we have negative 6c plus 3 plus 4c equals 0. Combining like terms, what we have is negative 2c plus 3 equals 0. Doing more stuff here, we have 3 equals 2c, and we can therefore see that c is equal to 3 halves. Okay, so we're gonna bank that for now, and we're gonna use the value of c in this first equation. So I'm just gonna put some line here using c equals 3 halves in equation 1. We have equation 1, remember, is a plus twice the 3 halves. What we have equals 1. So simplifying stuff, a plus this will be cancelled, so we have 3 equals 1. So a, therefore a is equal to negative 3 plus 1. That's gonna give us negative 2. So therefore a is equal to negative 2. Okay, fine. So we have two values of a and c. Let's now go above the same equation, and we want to find the values of b and d. I'm still gonna make use of substitution. So from b plus 2d equals 0, we can see that b is equal to negative 2d. I think that's much better. So using the value of b in, I'm gonna call this equation 3 and 4. In equation 4, we have, so we have 3 times negative 2d plus 4d equals 1. We have negative, therefore we have negative 6d plus 4d equals 1. Simplifying stuff, what we have is negative 2d equals 1. Hence, what we have is, dividing both sides by negative 2. D is equal to negative 1/2. And I guess that's one thing for D. Then we're gonna get the value of the other variable B. So using D equals negative 1/2, let me write it again, negative 1/2. In equation 3, we have 3b plus 4 times negative 1/2 equals 1. So we have, let's simplify, 3b plus, this will be cancelled up. This becomes 2, right? So 2 times negative 1 is negative 2 equals 1. So simplifying, 3b equals negative 2 will be transferred in the other side. So this becomes 2 plus 1 is equal to 3. Hence, your b is equal to 1. Now, putting them all in perspective, so we have, let me all write them here. Therefore, a equals negative 2, b equals, what's b? Positive 1. C equals 3/2, and d equals negative 1/2. Thus, your A inverse is equal to negative 2. Oh, sorry. Let's just recall. A inverse is equal to A, B, C, D, right? So we got the value of A, B, C, D. A is negative 2. B is 1. C is 3/2. D is negative 1/2. And there you go. That's the value of our matrix, of our inverse of A. We can also, what do you call it? We can also verify that if you want. How do we verify? To verify, we should show that A times A inverse is equal to A inverse times A, which is equal to I sub n. So since it's 2 by 2, we want to show that it's equal to I sub 2. But well, we got this equation from this, right? Let's skip that portion there, because this is actually that one, right? We got this value from, or the values of A, B, C, D from this equation here by definition. So A times A inverse is equal to I sub 2. So of course, if we're gonna input the values of A, B, C, D here, it should definitely be equal to your I sub 2, because that's where we got it from the first place. So I won't verify that already. If you want to verify, that will be your assignment if you want to. But yeah, we just got to that. Therefore, A inverse, sorry, that's not good to look at. A inverse, let me change it to yellow. A inverse is equal to negative 2, 1, 3/2, negative 2. Okay, and I guess that's it for this video. I'm gonna create another one similar to this so that you can see more examples. So thank you very much, and I hope you learned something from this. Bye.